Algebra 2, Chapter 5.3, Exercise 1 through 8. In this section, we are solving linear systems equations with three unknowns or variables. And in this set 1 through 8, we're going to use substitution, elimination, and matrices. I'm going to do the odd number problems here. Problem 1, solve the system using substitution. In substitution, we're going to look for our initial step. If we can solve for one of the unknowns quite easily, or variables. In this we have x minus 2y equals 0. If we add 2y to both sides of this equation, we're going to get x is equal to 2y. So now in the first two equations, and I'm going to work to the right here, we have 4 times 2y substituting for x plus y minus 2z is equal to negative 6. And continuing to work to the right, we have 4 times 2y is 8y plus y is 9y. So 9y minus 2z is equal to negative 6. So that's one equation with x knocked out of it. Now for the second equation, we're going to have 2 times 2y in place of x. We're going to have minus 3y plus 3z is equal to 9. And continuing to work to the right, 4y minus 3y is y. So we have y plus 3z is equal to 9. And now with this equation, this second equation below, y plus 3z equals 9, we can subtract to solve for y 3z from both sides. So minus 3z minus 3z. So we have y is equal to 9 minus 3z. So now we're going to take this top equation here, the first one we knocked x out of, and arrowing to it here. And I'm going to work to the right and substitute in for y. So we have 9 times 9 minus 3z. So that's substituted for y. And we have minus 2z is equal to negative 6. So just distributing the 9 here, we have 81. And then 9 times negative 3z is negative 27z. And then we have minus 2z equals negative 6. And then subtracting 81 from both sides of the equation, we have negative 27z minus 2z. Well, that's going to be negative 29z is equal to negative 87. And dividing by negative 29, we have z is equal to 3. Okay, and the next thing we're going to do is take this equation here. So I'm drawing arrows to where we're going. So we have y equals 9 minus 3, and replacing z with 3, we have 9 minus 9, so y is equal to 0. And then we go to our first equation we used to solve for x. So we have x is equal to 2 times 0, which equals 0. So we have x is equal to 0. So we solve for everything, and we can just try very quickly to see if we got this right. So we have 4 times 0 plus 0. 0 plus 0 minus 2 times 3 equals negative. So 2 times 3 equals negative 6 equals negative 6, check. In this next equation, we have 0 minus 0 plus 3 times 3 equals 9, check. And then we have 0 equals 0. So our ordered triple, and sometimes you see this as coordinate triple, is going to be the point on a three-dimensional coordinate plane, 0, comma 0, comma 3. So there we have it, solving this system by substitution. Next, we'll go to problem 3. Now problem 3 is the very same system, but we're going to solve this using elimination instead. And so what we're going to do is get x eliminated, and to do that we're going to take, I'm going to write this first equation here as 4x plus y minus 2z is equal to negative 6. And then the second equation, in order to eliminate, I'm going to multiply that second equation by negative 2. And so if we take negative 2 times 2x, we're going to get negative 4x. And then negative 2 times negative 3y is going to be plus 6y. And then we have negative 2 times 3z is going to be negative 6z. And then finally, negative 2 times 9 is going to be negative 18. And we've arranged it so when we add the second equation to the first, 4x minus 4x becomes 0. Y plus 6y is going to be plus 7y. And then negative 2z plus negative 6z is going to be minus 8z. And we get negative 6 plus negative 18 is going to be negative 24. Okay, so that's going to be one equation. And the next one, we're going to write the same thing, 4x plus y minus 2z is equal to negative 6. And now this last equation, we're going to multiply it by negative 4. So negative 4 times x is negative 4x. And negative 4 times negative 2y is going to be plus 8y. And then we don't have any z to multiply by. And then on the right side, we have negative 4 times 0 is going to be 0. And so when we add, we're going to do the same thing as we did in the last one, add 4x minus 4x is 0, and y plus 8y is going to be plus 9y. And then negative 2z plus 0 is going to be minus 2z is going to be equal to negative 6. So now we have two equations with two unknowns. And what we're going to do is multiply this second equation here by negative 2. And you'll see what we're doing here. So if we multiply the second equation by negative 2, we get what is that going to be? Negative 2 times 9y is going to be negative 18y. And then we're going to have negative 2 times 2z is, well, we want to cancel that. So instead of multiplying by negative 2, we're going to multiply by negative 4. I could see that mistake pretty quickly. Okay, so negative 4 times 9y is going to be negative 36y. And negative 4 times 2z is going to be plus 8z. And then negative 4 times negative 6 is going to be 24. And then adding these equations together, we have 7y minus 36y is going to be negative 29y, and negative 8z plus 8z is going to be 0. And the right side we have negative 24 plus 24 is 0. So we have negative 29y equals 0 divided by negative 29. So we have y is equal to 0. So that's one of our values. And then we can take, well, if y equals 0, we can substitute into this first equation here. So we have x is equal to, x minus 2 times 0 is going to be equal to 0. And so x is also equal to 0. And then we have the last one here. We want an equation just in terms of, well, we have x and y. We can use any of these equations now. So we have 4 times 0 plus 0 minus 2 times z equals negative 6. And if we divide by negative 2, I'm just going to write this down below. So negative 2z is equal to negative 6. And if we divide by negative 2, z is equal to 3. And so our ordered triple or coordinate triple is going to be the coordinate triple 0, 0, 3. Now it so happens that problems 1 and 3 are the very same system of equations, but being asked to work out using different techniques. Generally, I prefer elimination between the two, but that's a matter of convenience. I think both of these were pretty simple, really. Then 5, we're going to solve by elimination also. It's a totally different equation than the others. And what I'm going to do is eliminate the x's first from this. And we have, I'm going to take this first equation here, which is going to be 2x minus y plus 3z is equal to negative 12. And I'm going to multiply the second equation here by 2. And when I do that, we get negative 2x. And then we have 2 times 2y is going to be plus 4y. And then 2 times negative 3z is going to be negative 6z. And then 2 times 15 is going to be 30. And when we add these equations together, we get 0, 2x minus 2x, and then negative y plus 4y, we're going to get plus 3y, and then 3z minus 6z is going to be negative 3z, and then we're going to get negative 12 plus 30 is going to be 18. And next, we have, we've eliminated the x's really from these two, and so we can now, we're down to 2 equations. So I'm going to take this last equation here and multiply it by negative 3. And so when I do that, we get negative 3 times y is going to be negative 3y. And then negative 3 times 5z is going to be negative 15z. And then negative 3 times negative 6 is going to be 18. and we are going to add these two equations together. So 3y minus 3y is going to be 0, and then negative 3z plus negative 15z is going to be negative 18z, and then we have 18 plus 18 is 36. So now dividing by negative 18, we're going to have z solved for. So z is going to be equal to negative 2. Okay. So next, we can take z equals negative 2 back into this third equation here. So we have y equals, or y plus 5 times negative 2 is equal to negative 6. So we have y minus 10 equals negative 6, and then adding 10 to both sides, we have y is equal to 4. So now we have y and z. The only thing we don't have yet is x. So I'm going to take this first equation here. We're going to have 2x minus, and y is 4 minus y, plus 3 times negative 2 for z is equal to negative 12. And so we have 2x minus 4 minus 6 equals negative 12. So we have 2x minus 10 equals negative 12. And adding 10, we have 2x is equal to negative 2. And dividing by 2, go to the right here, x is equal to negative 1. So our ordered triple is negative 1, 4, and negative 2. And we can test this out quickly here. So if we have 2 times negative 1, that's going to be negative 2 minus y, so minus 4 plus 3 times negative 2, that should be, so negative 2 minus 4 minus 6 equals negative 12. That checks out. Then we have negative x, so negative, that's going to be 1 plus 2 times 4 plus, that'll be 8 plus 9 plus 6, 15, check. And the last one, we have y is 4 plus 5 times negative 2, so it'll be 4 minus 10 equals negative 6, check. So ordered triple here is the point in the three-dimensional coordinate plane, negative 1, comma 4, comma negative 2. Okay, the last one we're going to do in this exercise set says solve the system of 3 linear equations using matrices. And so we have this system of equations, and we're going to convert this to matrices. And to do that, we just change the numbers in the system to, well, just numbers. So we have 1x plus 5y plus 3z equals 4. So this is an augmented matrix. And we have 0x in the second equation, and we have plus 4y minus 1z equals 2. In our final equation, we have 6x minus 2y plus 4z equals 0. So this is our initial equation. And basically, we're going to manipulate this system until we get reduced row echelon form. We're going to get 1, 0, 0, some number I'm going to call A. And our second row is going to be 0, 1, 0, B. And then our last row is going to be 0, 0, 1, C. And when we do this, our coordinate triple is going to be X is A, Y is B, Z is C. So we're just going to go through manipulations in order to make that happen. Okay. Well, the first thing we're going to do is we already have the second row equal to 0. So we're going to concentrate on that third row. And so for that third row, we're going to take negative 6 times row 1 plus row 3. So I'm going to notate to the left of the matrix what we're going to do. So I'm going to rewrite the first and second rows. So 1, 5, 3, 4. And the second row is 0, 4, negative 1, 2. And the last row, we're going to take negative 6 R1 plus R3. Well, negative 6 times 1 is negative 6 plus R3, that's going to be 0. And then negative 6 is going to be, times 5 is negative 30, plus negative 2 is going to be negative 32. And then we have negative 6 times 3 is going to be negative 18, plus 4 is going to be negative 14. And then negative 4, or 4 times negative 6 is going to be negative 24. So that's what that one is going to be. And then continuing to the right, we're going to take, on this bottom row, we're going to take 8 times row 2. So 8 times row 2 plus row 3. So we're going to keep rows 1 and row 2 the same. So we have 1, 5, 3, 4. And then we have 0, 4, negative 1, and 2. And that thing there almost looks like 34. Let me go ahead and move that over a little to the right. That looks a little better. Okay. Well, we have 0 here, and 8 times row 2 times row 3, well, that's going to be 32 minus 32, or 0. And then we have, we're going to have negative 8 minus 14 is going to be negative 22. Yeah, negative 22. And then 8 times 2 is going to be 16. Plus R3. That should be 0. Let's see, 8. R2 plus R3. So 8 of R2 that should be 3 there. Yeah, that's what happened, this transposition. So 8 of R2 plus R3 is going to be 24 minus 24, or 0. Okay, next, we're going to take, in the third row, we're going to get rid of this negative 22 and make it 1. And to do that, we're going to take negative 1 over 22 times R3. We're just going to rewrite rows 1 and 2. So we got 1, 5, 3, 4, and then 0, 4, negative 1, 2, and then here we have the third row, we have 0, 0, and negative 1 over 22 times 22 is going to be just 1, and then 0 by the same is going to be this. So what we've done is we found that our value of z is going to be 0. Okay, the next step we're going to do is we're going to take R2, row 2 plus row 3 right in the middle, and we're going to bring over row 1 and row 3. So we're doing elementary row operations just one at a time. 1, 5, 3, 4, and the bottom one we bring over is 0, 0, 1, 0. And then we're going to take row 2 plus row 3, so we have 0, and then 0 plus 4 is going to be 4. 1 plus negative 1 is 0, and the last one we have is 0 plus 2 is going to be 2. So that's what we have there. I'm still messed up here because I'm still haven't carried over. It should be 3. Let's fix that. Gotta keep track of things. And this will be 3 over here. Okay, so we have that. The next step we're going to do is we're going to take 1/4 of R2, because we're going to get this 4 to be a 1. So we put 1/4 of row 2. And then we're going to bring over row 1 and row 3. So we got 1, 5, 3, 4. The bottom one is 0, 0, 1, 0. And we take 1/4 of row 2, we get 1/4 of 4 is 1, and then 1/4 of 0 is 0. 1/4 of 3 is going to be 3/4. And now we have our y value of 3/4. And the next one we're going to do is we're going to take negative 5 R2 plus R1. And what we're doing is we're going to work on that first row. We've already covered our second and third row are already good. So we have 0, 1, 0, 3/4. And our last row is 0, 0, 1, 0. And then we have negative 5 R2 plus R1. Well, we're still going to have 1 here. So negative 5 R2 plus R1, that's going to zero this out here. Negative 5 R2 plus R1 is going to be 3. And negative 5 R2 plus R1, well, we're going to have this negative 5 times 3/4 is going to be negative 15/4, and 4/4 is going to be plus 16/4. So we're going to have 1/4 here. And the very last thing we're going to do is take the top row, negative 3, R3 plus R1. And that should fix everything for us. And I'm going to write down rows 2 and 3 here. So we got 0, 1, 0, 3/4. In the last row we have 0, 0, 1, 0. In the top row, negative 3, okay, negative 3 R3 plus R1, that's just going to be 1, 0. And negative 3 times 1 is negative 3, and negative 3 plus 3 is 0, and then negative 3 plus R times 0 plus R1 is 1/4. So what we have here is the coordinate triple. We have our x value is going to be 1/4, or 0.25. Our y value is going to be 3/4, and our z value is going to be 0. And so that's what we have. And eventually you're going to find out how to do this in the calculator, where the calculator will get all this for you. And then I'm not going to do this one, but number 8, you're free to use the solving system of linear equations using method of choice. Generally, I like to use elimination. I hope this has been helpful to you. Good luck, and thanks for viewing.